Hey everybody, it's me, John Daly. I'm going to introduce my OpenGL project, real-time scene renderer that I completed over the course of 6 weeks. Originally, this project was created in response to a graphics programming course assignment that I had in university. And as it progressed, I kind of liked what I was making, and I decided that I would make it actually into a prototype for systems that I would hope to use in future game development projects. The core feature of this project is an instance terrain renderer capable of drawing tile-based world efficiently using texture arrays and GPU instancing. In addition to that, the project also includes a custom model transformation system, dynamic, directional, and point lighting, and day and night cycle on a cubemap Skybox, and a custom rendering pipeline tying everything together. This project was written in C++ and GLSL using OpenGL 4.6, along with the GLFW, GLAD, ASSIMP, SCB image, and GLM libraries. I've always kind of had an interest in RPGs, and especially games with medieval fantasy, science fiction, and modern fantasy type settings. One of my long-term goals for this prototype is to learn how to develop a short RPG or exploration-focused game, and then use the project as a learning experience and an early technical foundation for that idea. My primary goal during development was to create a flexible terrain system that allowed me to construct a larger environment without manually hard-coding every object or terrain tile. To support that workflow, I also built a lightweight terrain editor capable of generating map data files that could later be loaded directly into the renderer. Now, let's take a quick tour of the scene. This bridge here was one of the more difficult assets to integrate into the project because it was, when it was imported, the coordinate system was off. It didn't align correctly with the scene, so I had to write multiple corrective rotations, and then after that I had to do several scaling adjustments so that before it would fit naturally into the environment. And this is actually not a super great bridge, but it was something I was able to find for free on Polyhaven or on the other one was I don't remember, but that's okay. The lanterns, in addition to being cool little deals, serve as point light sources as well. I actually had to make the light itself come a little bit off the top of the light so that it could actually make it out of the inside of the object. Maybe there's some tweaking that I could do later to get it to actually operate properly from inside of the lantern itself. The boulders here also pulled from lanterns, boulders, and the bridge were all pulled from a different sources on as an open source modeling assets. And it sort of served this boulders was I used it to test importing, scaling consistency, lighting responses to day-nighttime conditions. It's got multiple surfaces that it can that the light can reflect off of, and a roughness map that lets me see how the light reflects off of it in different ways from the different normal maps of the bowl. The terrain itself is built from individual texture tiles rendered through a tile renderer system. The different terrain types include rivers over here, dirt paths. So we got walking paths through grass. You got dirt. You've got river. You've got lake. Go deep water and shallow water. And they're combined together to create the environment. So, sorry about that. I accidentally closed the scene render, the graphics render. The camera uses a first-person perspective and view matrices to create the illusion of depth and scale within the world. And the cubemap Skybox helps sell the environment by surrounding the scene with a full background texture set. Its brightness changes dynamically alongside the directional sunlight to support the day and night cycle. Now, so the tile renderer class here that I've got on screen is intended to become part of the larger rendering architecture. My initial plan was to separate the engine into dedicated render classes, including a tile render, model render, effect render, each responsible for managing a different category of scene objects. Due to time constraints during my project, I eventually shifted toward directly managing most scene objects inside of the main loop itself. The tile renderer was the only renderer subsystem that became fully generalized before the project deadline, and I abandoned fixing the flower render and effects render for this project at least. The tile renderer uses instance rendering to efficiently draw tiles, a large number of tiles with a single draw call. The texture arrays are used so that multiple textures can be accessed within a single rendering batch. For model rendering, I created a lightweight transformation structure. It stores pointers to models, along with all transformation information required to render them, including position, scale, rotation axis, rotation angle, and optional correction matrices for imported assets. That is right up here. The model transform has a pointer to the model, and it has position, scale, the rotation angle, and the correction matrix to get it in line with the scene. And the models are imported using ASSIMP. Each has its discrete structures. The lighting throughout the scene is actually here in the shaders. Fragment shader has built-in form, shader calculations for lighting. The directional doesn't attenuate because it's from a distant, very bright object instead of a close by, not as bright object. So it won't attenuate over distance like point lights look. Point lights are attached to scene objects like lanterns, and the directional light is that drives the day-night cycle is attached to a sun. It's an object in code, but not an object in the scene. And then finally, the cube map is rendered using the Skybox. The camera system represents the point of view of the player from their frame of reference within the scene, and supports mouse click and first person movement using the keyboard. And then that's what that is. Going back to our main loop, we actually create all our objects initially, the tile renderer, each of the models in the model transforms. And then we do our point lights, add them to the lamp positions and a point light. And then we have their tile renderer that loads our tiles in and draws them. And then we get to the main model loop. After the initialization, the program enters the main render loop. At the start of each frame, the frame buffer is cleared to remove the previous information. The previous frame's information, then the timing values are updated so that movement and animations remain frame rate independent.
These are the timing values.
We do our sun directional lighting here as well. After that, we process the input with our helper method, process input. And that's right down here. And it's just key presses and the mouse movement. Once a scene's completed, we use the lighting data to pass it to our model shader and the tile shader. We update the tiles. We draw our tiles here and set our lighting here, and then we draw our tiles using the end function in the renderer tile renderer class. After that, we do all of our Skybox rendering, and that's because the Skybox, the model, the rendering order is extremely important for models, then tiles, then Skybox because of depth testing. So in order to get everything correct, models must be drawn first before we do the tiles, and the tiles and models have to be before the Skybox. After the rendering is complete, we swap buffers and pull events for the next frame. That includes the escape button, which closes the game. So I actually had quite a few problems when I was doing this, including many of my original helper functions and functions in the tile render class actually had took copies of every item instead of the reference, so that it would spend a lot of time copying vectors and models into each of these methods, and that was time consuming. So what we did instead was what I did instead is I made all of these helper methods use references instead, so that we could save some time, some compute and model during the modeling. And some counting the lighting systems, especially for the day-night cycle. Originally, the directional lighting system had a lot of a pretty strong ambient light component, and I had to do multiple iterations to fine-tune so the scene behaved more like real day-night cycle and less like a bad day-night cycle, I guess you could say. And the tile renderer with debugging became a little bit bit of a problem because of vector memory problems and ownership issues for the model pointers. These problems ultimately led to a deeper understanding of the memory management, vector lifetime behavior, and rendering state management systems within OpenGL. So I learned a lot there from those issues. I just created a short little blurb to describe the process of the architecture. So basically, the input from GLFW, the keyboard and the mouse, goes to the camera. The camera observes the terrain, the models, and the lighting. The OpenGL rendering pipeline renders everything from the point of view of the camera, and then that gets sent to your screen as the final product. And the rendering pipeline is just straight up and down. It's a pipeline, so it doesn't actually have any branches. It just goes update time in the sun position, pull inputs and events, clear the frame buffer, calculate closest lights and lighting, render the models, render the terrain tiles, and draw using instances. Render the Skybox and swap the frame buffers. And that is the entirety of that system. And that's the end of my presentation. In the future, I plan to do, this is just kind of a high-level overview of this project. In the future, I plan to do more in-depth looks at the tile renderer system that I used, the texture arrays and terrain rendering system, the lighting and shader pipeline, the model importing and transformation corrections, the camera system, debugging OpenGL, and asset preparation workflows in Blender, and the lessons that I learned while doing the render and things that I wish I did differently or had time to do differently. To make a more long-term project focused rendering on RPG style systems. Thanks for watching, and I'll see you in my next video.